Hey YouTube, today I'm going to show you the extreme dehydrating power of concentrated sulfuric acid. So I want to start with a warning. Whenever you're using concentrated sulfuric acid of this strength, you want to be extremely careful and wear goggles and gloves at all times. This stuff is very, very nasty if it gets on you. One, because it's a dehydrating agent like I'm about to show you, and two, because it's a very powerful acid. So what I've got is about 96% sulfuric acid here. It's liquid fire drain cleaner. It's colored that way probably because of dissolved carbon, just because this particular stuff is usually a waste product from other industrial processes, so they don't really go to a lot of trouble to purify it. But the color's not really going to make any difference. So anyways, what I'm going to do to show how powerful it is actually use a crystal of copper sulfate that I grew this myself. It took about a month to grow, but I think this is a worthy experiment to destroy it. But this crystal is copper sulfate pentahydrate. So for every molecule of copper sulfate, there's 5 molecules of water locked in the crystal structure here. So sulfuric acid at this concentration is so powerful of a dehydrator that it'll actually suck the water crystallization right out of the crystal and turn this into anhydrous copper sulfate, which is quite different and is actually a pretty good dehydrator in its own right. So all I'm going to do is pour this acid directly over the crystal, and we'll let it sit for a while and watch what happens. So this is generally going to take a good amount of time, especially because this is a monolithic single crystal. But what's going to happen is the acid is going to, like I said, suck the water of hydration right out of the crystal itself, and it's going to turn it into anhydrous copper sulfate, which is a white powder. So if all goes well, this blue single large crystal is going to over time crumble into a white powder. So we'll let this kind of stew for a little while and come back and see what it looks like later. So now it's only been 5 minutes or so, and you can see that the acid is already attacking the outside of it and turning it white. It's been about an hour and a half or 2 hours now, and you can see that it's covered in this nice coating of anhydrous copper sulfate, and it's pretty much going to stay like this for quite a while. The biggest change happens in the beginning when there's a lot of surface area exposed, and then once it builds up this layer of anhydrous copper sulfate, it kind of takes a while for the water to sort of diffuse out of it. But we'll leave it alone like this for a while and come back in a bit. Alright, it's been 4 months since the last time I filmed this, and this has just been sitting on my table for the whole time. And you can see now it's pretty well crumbled apart. So let's take a look and see how powdery it actually is. So I've just got a glass stir rod here I'm going to poke at it with. Yeah, wow. It's entirely crumbled into this white powder. So the sulfuric acid has completely dehydrated the copper sulfate crystal and turned it into anhydrous copper sulfate powder. Probably didn't need to take the full 4 months. I just never messed with it because it never actually fell apart. It still had the shape of the crystal there. But it's definitely completely powdered. That's pretty amazing. So I decanted the acid, and it turns out it's actually not entirely white. It's still got a bit of a blue tint to it. So there's still some water, but it dehydrated it enough to destroy the crystal at least. So I'll show you actually you can rehydrate it just by adding some more water. So I just have a little bit of water here. Add some of that. And you can see the blue color immediately deepens. And pretty quickly we arrive right back at the nice deep blue color of hydrated copper sulfate. Thanks for watching. So as I was cleaning up the acid solution from this experiment, I noticed a really neat thing happen. So this is the acid that I've diluted with water quite a bit, and some of the copper sulfate has dissolved into it. So the blue copper sulfate mixed with the orangish acid, and it's made this sort of greenish colored solution. And what I'm adding to it is potassium hydroxide to neutralize it. And then once it's neutral, I'll be able to just pour it down the drain, because all it's going to have in it is potassium sulfate and a little bit of copper sulfate, which I wasn't too concerned with. But take a look at what happens when I add the hydroxide. We get this immediate precipitation of a blue cloud. And when I stir it around, the blue disappears for the most part. There's still a little bit around because I believe I'm near the end point now. But what that actually is the copper sulfate. The copper sulfate will stay as the sulfate as long as there's excess acid. But when you start adding potassium hydroxide, once the hydroxide has used up all the acid, it starts to precipitate copper hydroxide, which is that really nice blue that you saw. So that's a really nice way of knowing when this solution is neutral, because when you have a copper hydroxide precipitate, you know that all the acid has been used up. So like I said, what happens when you add this is you get this precipitate, and then the excess acid immediately reacts with it and forms it back into soluble copper sulfate. So we'll add some more. And again, you immediately see the blue precipitate of the hydroxide. And you see the difference. So now it's definitely neutral because we end up with this precipitate. And how about we test that, actually. I've got a little bit of pH paper here that we'll put in there. It looks like I overshot a bit, so it's blue, so it's basic. But you can see that that's a really nice indicator.